uh, is it on? Oh, well, alright, that's good. Well, I'm going to, test Newton's first law of motion with this watermelon, and, Newton's first law of motion states that every object in a state of uniform motion tends to remain in that state of motion unless an external force is applied to it. So, let's go see what happens. Well, as you can see, the watermelon right now isn't moving, but that's because there is, no external force applying to it to make it go into motion. Alright, so I'm guessing by the look on your face, we're ready. It's coming to you. Here, I'll be right down to check it out. Well, as you can see from the melon not in motion anymore, it's because gravity on the way down kind of slowed down a bit until it went to a stop, and unfortunately this thing wasn't destroyed. My mom would be pretty mad at me if it was. Next, I'll be testing Newton's second law of motion, which states the relationship between an object's mass, its acceleration, and the applied force. Acceleration and force are vectors. In this law, the direction of the force vector is the same as the direction of the acceleration vector. Well, first I'm going to try applying force to a bigger object, as you can see from my dad's car. Yeah. Alright, here goes nothing. Well, as you can see, the car didn't go that fast. Well, faster than I expected, but it still didn't go that fast. Now I'm gonna test it with an even smaller object. Here it goes. Well, as you could see, the smaller object went farther and faster. This homemade boxcar right here is a little something I'm going to use to test out Newton's third law of motion, which is for every action there is an equal and opposite reaction. Right, here we go. And that proves Newton's third law of motion. So in conclusion, all of Newton's laws of motion can happen anywhere around you at any time of the day, no matter where you are.